Here in this video, I am teaching you mechanics of structures. The course code for this is 22303. In this first video, we will take only the introduction for mechanics of structure. Now, before we directly start the mechanics of structure, we will take a revision or prerequisite, that is why force is a vector, what is an active force, what is a passive or a reactive force, what is the effect of force on a body, what is a stress, and what is a strain. All these things we are going to learn in this video. Now suppose Ram has 5 rupees with him. Sham gives him another 5 rupees. So the total money with Ram will be 5 plus 5 is equal to rupees 10. This is called algebraic addition, where there is no question of direction. So this is a scalar. And 5 plus 5, 10. This is the only right answer. 9, 11, any other than 10 is a wrong answer. Now we will come to force. Why force is a vector. Now this is a figure 1 and here this is a body. For this body, if this force P is applied along the positive x direction, it's shown in here, then this body due to this force will start moving in this direction. If I remove this force from here and apply it here along the negative x direction, then now the body will start moving in this negative direction. So here what happens is the direction of the force decides the effect on the body. Now suppose I add two forces. One is here along the positive x direction and another force I add here in the negative x direction. Now the question is, in which direction this body will move? Now, even though there are two forces, they are equal in magnitude and opposite in direction. Now they cancel the effect of each other and the body will not move at all. Here the body will be at rest even under the action of forces. This also you can very well imagine how this body will be at rest. Now let us come here to the figure 4. Now 1/4 here I am adding in the positive x direction and this force P is upward in the positive y direction. Now the question is, will the body move in positive x direction or will the body move vertically upward in the positive y direction? Question is, will the body move? Will it be at rest? The answer is the body will surely move because we have two forces in two directions. But in which direction it will move is a problem. And here, suppose P is 5 Newton and this P is 5 Newton. I cannot say that P plus P is equal to 10 Newton. P plus P is equal to 2P is equal to 10 Newton. This is algebraic addition. This algebraic addition we cannot do for a force because force is a vector and its effects on body depends on the direction of the force, and that is how the direction becomes very important. And how we solve it, which you have already learned in your applied mechanics, that is the resultant R is equal to under root P square plus twice P to P into cos theta. Or sometimes you call one force as P and another force as Q. And then you do the resultant of these two forces, which will give the same effect as it is given by the two forces. So this is how the force, for the force we cannot do algebraic addition, we have to do the vector addition. This is how we do the vector addition, and that is why force is a vector. We cannot do 5 plus 5 is equal to 10, P plus P is equal to 2P here. The value of P goes on changing. If the forces are applied like this, then it becomes P minus P is equal to 0, the effect is 0. If I apply both the forces here at the same point P, then it will become P plus P, 2P. And from this 0 up to here it is 2P, and in between it is 0 to 2P. And it goes on varying depending on what is the angle between these two forces. It depends on the theta, and this is a formula we find out the resultant using law of parallelogram of forces. And that alpha, which I have not written here, that gives us the direction of the resultant force. Next we will see what is a active force and what is a passive force or a reactive force. All of us know the Newton's third law of motion. To every action there is equal and opposite reaction. What is the example? Suppose this is a ball which I hit it on the floor here. Then when I hit it on the floor and apply the force, then this downward force is a active force with which the ball hits the ground and it bounces back. Now this bouncing back is the reaction offered by the floor, and that is a reactive force. Here what is to be understood is, if I lift this ball from a greater height and I apply a greater force, so if I increase the active force here, the ball will bounce back to a more height and the reactive force also will increase. So if I increase the active force, reactive force will increase and this height ball from the ground will increase. Now if I don't apply any force, but I gently keep the ball on the floor, touching the floor, so my active force, if it becomes 0, it will not happen that if I gently keep the ball on the floor, it will bounce up. It will not bounce. It will be here only. And if active force is 0, the reactive force is also 0. So if active force is 0, then reactive force is 0. It does not exist of its own, and that is why we call it a passive force, whereas active force exists of its own. Now here we will see what is the effect of a force on a body. Now, when we apply a force to a body, there can be a linear motion that the body starts moving in a straight line. Suppose if you add a pulling force or a pushing force, it will start moving in a straight line. Or due to the force, the body can have angular motion that the body can turn. When we turn our handle of a cycle or a two-wheeler, it turns the body. So that turning effect, or when we open a door by applying a force, then that is also an angular motion. We turn the shutter of the door. Then the body can have acceleration, that is increasing speed. So when sitting on the two-wheeler, you accelerate the body, or in a car you press the acceleration and you increase the speed of the body. That time we are applying a force, and that is the effect that the body accelerates. Similarly, when we apply the brakes, the body retards. So there can be the effect of retardation. Applying a brake is also a type of a force which we are applying to the body, and the effect is retardation. Body can change in its size and shape. Sometimes when you apply a force to the body, there is no motion, but the body gets compressed. Suppose there is a sponge kept on a table and we press it with our hand, then that sponge gets compressed. It changes in its size and in its shape. So few bodies, when we apply a force, they change in its size and shape. Sometimes the body can break. Suppose we take a chalk and bend it, try to bend it, then it will break into two pieces when we apply the force. So sometimes when we apply a force, the body changes in its shape. It can bend, it can crack, or it can break. But sometimes in the body, when we apply a force, we cannot see all these 6 effects. But what happens is stress and strain is developed in the body. So now let us see what is a stress and what is a strain. What is a stress? Now this is a here wooden platform and a body is kept here, say a body is kept here. Now, the self-weight of each and every body is active force and it will act vertically downward. Weight is equal to m into g. So it is very parallel to F is equal to m into A. So this weight will act vertically down. Now when I keep a small body here on the table, there will be no linear motion. There will be no angular motion. There is no acceleration, no retardation, no deformation of the body, no change in shape of the body. So what is the effect? What is the effect is a reactive force is developed here, which is equal and opposite. A reactive force, an internal resisting force is developed here. A reactive force is offered by the table. And this internal resisting force which is offered by the table divided by this contact area here is called as a stress. And if that contact area is A, then what happens is this R is equal to W. So the stress is basically internal resisting force upon contact area is R upon A. But in this case R is equal to W. So here stress is equal to W upon A. I substitute value R as W, where A is the contact area. Now, it is very difficult to imagine what is a stress. So, we can have some example. Let's suppose this is a hand, and a boy of say 20 years is told that I am going to put some weight. Suppose this is a weight of say 1 kg, and you hold his hand horizontally. When you keep the weight at that time also he has to hold the hand horizontally. When you keep the weight, some stress will come on this hand. But if he is capable of resisting it, if he can offer a resisting force, then he can keep the hand horizontally. So if W is equal to R, then the hand will remain horizontal and sigma Fy here will become 0. W will be equal to R. So the hand will remain horizontal. What if W becomes greater than R? That this weight W is say 10 kg so high that he cannot resist the force. Then what will happen? R is suppose less and W, the active force, is more. This weight will slip from his hand and will move downwards. This body will start moving downward because this W is greater. This W is greater than R. If the weight is heavy and he cannot bear the weight, then this will start moving down. So here the hands are weak to give sufficient reactive force. So if the hands are weak to give the sufficient reactive force, the weight will fall down. Okay. What if W is less than R? That is, weight is smaller than the reactive force. If this happens, then R is a bigger force, so the body should start moving up. The body should start moving upward, leaving the hand. But this does not happen as the reactive force is a passive force. This reactive force is a passive force. So here also, when you keep the body on the table, it never happens that this W is small and this reactive force is more. If this reactive vertical force becomes greater than W, as soon as you keep this block on the table, this body, due to this more R, it will start moving upward. But this doesn't happen. Why? Because reactive force is a passive force. It does not exist of its own. And most of the time, it is either equal or it is sometimes if the body fails to offer a reactive force. Then this table, suppose I go on increasing this W weight here, I go on putting more and more and more weight, and this table is now not giving the reactive force and it is not equal to R. Then due to this higher W, this will bend. This tabletop will bend or it will break and this body will start moving down. But reactive force is a passive force, so it is never greater than W. It will never happen that you keep some block on the table and the reactive force is so high and the body starts going upward. It doesn't happen. This is what is a stress and how the stress is developed in a body. The stress is developed by the material, and in strength of material or mass, we study different materials and how much resisting force they develop and how much stress is developed by the body and what is the stress carrying capacity of the body. That is what we study for the different materials in strength of mechanics. Now or mechanics of structure. Now we will see what is a strain. Now here this yellow color is a body and I am applying two forces here. So they give a tensile force, and due to this tensile force, if the initial length of this body is L, it will increase in length by delta L. Increase in length is shown by red. So there can be small increase in length due to this force P. And this is the length and this is the cross section of the body. If I see it from this angle here, then this is the cross sectional area A of the body. The cross section is rectangle. Now if I take a section anywhere here like this section is XX, cut a section, and I consider the left hand side of the section, then this is the force P here, and at this section internal resisting force which I have shown here, internal resisting force is developed throughout the section and it may not be very uniform, but we assume it to be little uniform, and these are the internal forces resisting force, and the total resisting force is R, internal resisting force which is developed within the body which resists this force P. If I take the right hand side of the section, then this is the body, right hand side of the body, this is the force P applied, and here I am showing the internal resisting force. So what is the stress here? The stress here is internal resisting force divided by cross-sectional area. Now this force, the resisting force is developed throughout the cross-section, that is throughout this cross-section of the body. So this full cross-section offers a resisting force. So this internal resisting force divided by the cross-sectional area is called as stress. And this internal resisting force, if it is R, then it is R upon A. Here P is equal to R, so sigma will be P upon A. What is a strain? Strain is change in dimension to original dimension. Now here change in dimension is increase in length, that is delta L. So change in length upon original length, so delta L upon L is called as strain, that is epsilon. It is along the length, so sometimes it is also called as longitudinal strain. So this is how we saw here stress and strain. Thank you.